Hey guys, it's Miss Turnbull here with another video. This week we started trigonometry. Today is when we're really going to start to get into it. Today we are going over the first of our trigonometric ratios. I'm going to give you a basic introduction to using these ratios, and then we're going to talk about the tangent ratio, and specifically using the tangent ratio to solve for the length of a side of one of these right angle triangles. So there's some terminology we have to review first and some labeling strategies. So we're going to go over the labeling of triangles first, then we will move on to some of the terminology, and then we'll actually start getting into the math associated with these triangles. So when we label or name these triangles, we generally utilize letters. These sides will be labeled with capital letters, and the angles, or also known as vertices, will be labeled with lowercase letters and the angle symbol. Okay, so you'll see we've got side A here, side C here, side B here. We've got angle A, angle B, angle C. Okay, you can switch these letters up when you're labeling a triangle. It doesn't really matter what letters you give them, just as long as you maintain consistency when you're doing your math. Okay, when it comes to terminology, there are a few different things. One of these you've seen before, and three are probably new to you. So the first one is the reference angle. This is the angle that we're going to either use to solve the triangle or the angle that we're going to be solving for. We're not going to worry about that second type of question just yet. That'll be what we do at the end of the unit. For now, we're going to be using the reference angle to solve the triangle. The hypotenuse, as we talked about in the last video, is the side that is across from the right angle. The opposite side is always the side that is across or opposite of the reference angle, not the right angle. This time it's the reference angle. And the adjacent side is always the side that's connected to the reference angle that is not the hypotenuse. Okay. Also of note, this is called a theta symbol. This one right here. We use this to represent the reference angle. Okay, so don't be surprised by seeing theta a lot in this unit. It's a very common symbol to represent an unknown angle. So there's a saying that helps us remember these ratios, and that saying is so ka TOA. Today we're going to be dealing with TOA. All right. In the coming weeks, we'll talk about sine and about cosine. So sine uses so and cosine uses ka, but tangent uses TOA. Okay, it'll make a little bit more sense as we move forward here. So let's practice labeling triangles. Okay, so if we were to label this triangle here, I'm gonna just always put C for the hypotenuse. Okay, which means I can assign A to this one and B to this one if that's what I want. All right, and then angle A, angle B, and angle C. All right, let's say we were going to do one with D, E, and F. All right, we can do that. Okay, it's all the same. Okay, it doesn't really matter. When we're talking about, though, those sides with the triangle, remember we talked about opposite and adjacent. And the third one, of course, is the hypotenuse. And we already know that this one is the hypotenuse, right? If this is our reference angle, this is our opposite side, and this is our adjacent side. Our opposite side is across from the angle that we're using, the reference angle, and the adjacent side is the side that is attached to the angle but is not the hypotenuse. Okay, this is just an example to show you how this hypotenuse, adjacent, and opposite would work out if we're talking about this angle. If we were talking about this angle instead, these two would be reversed, but the hypotenuse would still be the same. Okay. So at this point, if you're following along with the notes package, I suggest you pause the video and take a few minutes to complete the investigation on page 6. It's a little bit of a kind of an exercise to give you some practice with just the concepts behind this. It'll take you a few minutes. I would recommend that you pause the video and do that now. before you move forward. All right, I've assumed that you've done that investigation and that we can move forward. So we're dealing with the tangent ratio. Like I said, TOA, all right? And the reason why it's TOA, T-O-A, is tangent equals opposite over adjacent, okay? And this is the structure of all of the basic trigonometry ratios, okay? So it always goes 1 theta equals 2 over 3. 1, 2, 3. Okay. Tan theta equals opposite over adjacent for tangent. Okay. Tan theta equals opposite over adjacent. This is the reverse form of this function. The inverse, actually, I think is the proper term for it. We are not going to use this yet, but this is the formula that you have to use when you're trying to figure out the angle and you have the two sides. Okay, so if you have the two sides and you're looking for the angle, this is the formula you have to use, but we're not going to do that today. Today, we're only going to look at questions that use this formula. So also of note, when you are using a calculator for this, it is very important that you make sure your calculator is in degree mode. If it is in radian, you will get all of your answers wrong all of the time. If you're not sure how to change the mode on your calculator, send your teacher an email or Google it. Okay, there should be guides available telling you what buttons to press. Normally, it's just a mode button. If we look at the Windows calculator, I'll pull it over onto this side here so that you guys can see it. It's right here. So if I click on this, it turns it into radian. But I click on this again, I want it to be in degree. Okay, this is the common kind of shrunken term for this. You'll see it represented by this on your calculator, DEG, degree. Okay, so let's actually get into some practice here. So we're gonna write the trigonometric ratio for tan A and for tan B as a fraction and as a decimal to 4 decimal places. Okay, so we're just looking at the ratio. All right, so tan theta is always how it starts. Now we remember tangent is opposite over adjacent. This is how we abbreviate them. Tangent equals opposite over adjacent, okay? TOA. So for A, okay, tangent of A, opposite is going to be 8, and adjacent is going to be 6, because this is the hypotenuse. It's opposite of the right angle. We can't use this one when we're dealing with tangent. Okay, there's no hypotenuse in this formula. Okay, for tan B, now the opposite side is 6, and the adjacent side is 8. Okay, so this is a fraction. We can actually simplify this one, 3 over 4, or this one to 4 over 3. This, as a decimal, will work out to 1.33 repeating. And this one here is going to work out to 0.75. Okay, this is what all you have to do when it comes to writing the trigonometric ratio for each of these two angles as a fraction. Here it is as a fraction, and here it is as a decimal. Okay, for the second one, here it is as a fraction, and here it is as a decimal. Okay. This says determine the tangent ratio to 4 decimal places. So the tangent of 15 degrees. We pull up our calculator here. And all we have to do is type in our degree, 15, and we want to use tangent. And that tells us that this is 0.2679. That's our answer. That's how easy that was. Okay, we just had to put in the tangent of 15. If you don't want to put in 15 first, you can do tangent Actually, let's clear this. It just thinks that I'm adding that on. Tangent. Oh, it looks like for these ones, you have to do 15 first. Okay. In many other calculators, in most other calculators, you should be able to hit tangent and then the angle. It just looks like the Microsoft one doesn't really work that way. Okay. Last page with a couple of examples. These ones are asking us to find a side when we know an angle. Okay, so let's get into this. Again, we'll just write our ratio here. Tan theta equals opposite over adjacent. This is our angle here. It's missing a little degree sign, so I'll add one. This is our angle here. So this is theta, which means for this one, tan 55 equals opposite is x and adjacent is 6. Now our problem is we need to solve for x, right? 6 is connected to x through division, which means we need to multiply it across in order to get it over to the other side. So we're going to get x equals tangent of 55 times 6. So let's grab our calculator here. 55, we want tangent, and then we're going to times this number by 6. And that gives us x equals 8.57. Okay, so side x is 8.57 units long. Okay, let's take a look at our second example here. Still same formula. Our angle this time, and again, it's missing its little degree sign. We'll just add one in there. It's tangent of 23. Opposite this time is 4, and adjacent this time is x. So we need x by itself. So what we're going to do is multiply x over to this side. We end up with tan 23 x equals 4. And then we're going to divide both by tangent of 23. So we get x equals 4 divided by the tangent of 23 degrees. So 23 degrees, we want tangent of that. Okay, and I'm going to copy that. And then we are going to say 4 divided by that number. And that tells us that side x this time is 9.42 units. Okay, so these are the two different types of questions that you're going to end up with when you're trying to find a side, either where you're trying to find the opposite side, wherein you're going to have to multiply the two together, or where you're trying to find the adjacent side where you're going to have to divide them. Okay, they're all just manipulations of this formula. So if you can remember this formula, that will help you a lot in solving these questions. Okay, so in the next videos, next week, we're going to be talking about sine and cosine and using them to find the sides of the triangles. And then after that, we'll be dealing with finding angles when we know the sides. I hope this video was helpful. Stay tuned for your practice quiz later in the day. If you have any questions, please make sure you contact your teacher. Don't allow yourself to sit in the dark on this. Trigonometry is not the easiest unit. We know that, and we want to help you through it. So if you're struggling with it at all, even a little bit, please make sure you seek out some help from your teacher. All right, guys, I'll see you next week on Tuesday.